Dear students, in this session, we'll discuss about vertical distribution of groundwater. How the groundwater is distributed. That you can see. Look at the screen. The ground surface you can see. Below that, there are left side. There are two main zones we have shown. That is zone of aeration or Veeresh water. Below that, the groundwater or the uh, phreatic water. Below the water table, the phreatic uh, water you can you can see, and above that the zone of aeration or Veeresh water. In the zone of aeration, the again we can subclassify the zones, three zones. One is the topmost zone is soil water zone, below that intermediate Veeresh zone, and below that the capillary zone. The water table below the capillary zone, the zone of saturation is seen. This saturation means the water availability in the rocks. The subsurface occurrence of groundwater may be divided into zone of aeration and saturation separated by the water table. On most of the land masses of the earth, a single zone of aeration overlies a single zone of saturation and extends upward to the ground surface as shown in the figure you can see on the screen. The water table is generally considered to be the lower surface of zone of suspended water and the upper boundary of the zone of saturation. The water table may be defined as the contact plane between free groundwater and the capillary fringe. Water table fluctuates with weather conditions and it varies with the topography of the region. The water of saturated zone is usually denoted as groundwater or phreatic water. Zone of aeration or zone of suspended water. The zone of aeration consists of interstices occupied partially by water and partially by air. This zone is divided into three subzones. Next is soil water zone, the belt of soil water which constitutes the upper portion of the zone of aeration is limited to the surface layer penetrated by roots. Its thickness varies with the soil type and vegetation. The belt of soil water is the great reservoir of available root moisture upon which plant life depends. The water of the zone of aeration includes stored water occurs as attached films on the surface of openings and as wedge shaped bodies at the junctions between interstices. The water here occurs in thin films of moisture known as hygroscopic water, which is remained absorbed on the fine grained soil particles. Temporarily, the soil water zone may contain water in excess of capillary water from rainfall or irrigation. This gravitational water drains through the soil under the influence of gravity. Intermediate Veeresh zone This zone extends from the lower edge of the soil water zone to the upper limit of the capillary zone. The thickness may vary from zero, where the bonding zones merge with a high water table approaching ground surface, to more than 100 meter under deep water table conditions. The stored water above the capillary fringe is called pellicular water. The excess water is free to travel downward towards the water table is referred to as gravity water or Widow's water. Water moves freely under the control of gravity only after the grains or rock surfaces have been coated with pellicular water. Capillary zone. The capillary zone extends from the water table up to the limit of capillary rise of water. The water of the fringe is held above the water table by capillarity, which is defined as the property of tubes with hairline openings when immersed in water to raise and hold water above the static level of the water in which they are immersed. This water may be denoted as capillary water or fringe water. The capillary zone will vary inversely with the pore size of soil or rock. Just above the water table, almost all pores contain capillary water. Higher, only the smaller connected pores contain water. And still higher, only the few smallest connected pores contain water lifted above the water table. The capillary fringe is from a fraction of an inch to 1 feet, about 10 feet thick, depending upon the size of the interstices and texture of the material just above the water table. The limit of capillary lift varies inversely with the diameter of the capillary openings. Capillary movement is relatively rapid in the larger capillary openings of small lift, that is 1 to 3 feet, and slow in smaller tubes with higher lift up to 10 feet. Zone of saturation. In the zone of saturation, all the interstices or openings are filled with water under hydrostatic pressure. Hence, the porosity provides direct measure of the water contained per unit volume. It is from this zone that water is available for the development of satisfactory water supply system. If water moves through an interconnected body of pervious material unhampered by impervious confining material, it may be denoted free groundwater, which moves under the control of the slope of the water table. Confined water moves in strata, conduits, or veins under the control of the difference in head between the intake and discharge areas of the confined water body. Fixed groundwater is held in small openings which resist water movement under the usual hydraulic gradient existing underground. So this is about the vertical distribution of groundwater. Thank you.